In this lesson, I am going to discuss how you can interface ultrasonic sensor with Arduino. So first, why we need a sensor like ultrasonic? Ultrasonic sensors use ultrasound waves to measure obstacle distances. These are used to transmit and receive ultrasound waves. Now, ultrasound waves can work underwater. That's why the applications are huge. There are many ultrasonic sensors are available in market, but for learning purpose, we will use the cheapest one available, that is HCSR04. So how an ultrasonic sensor works? What is the working principle? See, an ultrasonic sensor has a transmitter and a receiver. So by simple physics, when the sensor transmits a sound wave, if there is an obstacle, the sound wave will get reflected. This is the simple physics. The sensor also has a receiver. So if reflection happens, then the sensor will get to know. Now the question is how it can measure the distance. By calculating the travel duration. Like a timer will start from the beginning of the transmission and say reflection happens. When the receiver will receive the sound, the timer will be stopped. So we'll get a time. Now we can calculate that how far the sound wave can go within the time we got from the timer. Remember, we know the velocity of sound. Now let me show you how we can interface the sensor with Arduino. For that, let's see how it looks. So this is HCSR04. This is the transmitter, C marked as T, and this is the receiver marked as R. These are the interfacing pins. You should apply 5 volt to VCC, ground to ground. Trigger pin is connected to the transmitter. If you apply a pulse here, the sensor will transmit sound waves. Echo pin is connected to receiver. So when this pin is low, that means the sensor received a reflected sound wave. How you can then interface it with Arduino? Let me take you through the steps. First, send a 10 microsecond pulse to trigger pin. 10 microsecond pulse means this pin should be high for 10 microsecond. After that, the sensor will transmit a sound wave. Now you can calculate the time using pulse in function until it receives a low at echo pin. For that, you need to write pulse in within bracket echo, high. Remember, you are calculating the time for which the echo pin is high. Pulse in will return the time in microsecond. So when the pin is low, that means the sensor just received a reflected wave. Now the calculation part. So in a second, sound can travel 34,300 centimeters. And in a microsecond, it can travel 343,000 into 10 to the power minus 6, that is 0.0343 centimeters. The velocity of sound is 343 meters per second. That is the standard value. So here we are calculating the distance in centimeters. That's why I have done this. So total distance traveled by the sound wave is the time we are getting from pulse in into 0.0343 centimeter. So obstacle distance will be the total distance divided by 2. Why? Because the sound wave more precisely, traveled same distance twice. One for transmission and another for reflection. So this is how you can calculate the distance. Now I'll do an experiment with HCSR04. So my sole objective will be the distance measurement in real time. And my methodology will be, I'll use a packet as the obstacle. I'll move it in front of my HCSR04 sensor, then print the sensor data on serial monitor. So for my experiment, see my circuit connections. The circuit connection is very simple. There are 4 pins. So VCC is connected to 5 volt through this red wire marked here, and ground is connected to ground through black wire. Trigger pin is connected to pin number 8 through this yellow wire, and echo pin is connected to pin number 9 through this green wire. Now I think you have the clear idea about the circuit. Let's make the connections then. So this is my setup. This is HCSR04. I have 3 wires and breadboard and Arduino Uno. So here I'll be experimenting with this. So this is HCSR04 sensor, and let me show you this. This is VCC trigger. The R written cylindrical sensor is receiver and T written cylindrical sensor is transmitter, and VCC ground, trigger and echo. These are the 4 pins will be used for interfacing. So now I'll connect it on the breadboard and subsequently I'll make the connections. So here I'm connecting it on breadboard. So let me connect VCC, ground, trigger and echo. So in this way I am connecting the wires. So here red one, not quite red, but this color wire should be connected to VCC, and black wire should be connected to ground. So here the black wire, I'll connect it to ground. Then comes this white wire, which is echo, gray wire is trigger and red wire is VCC. So let's connect it to ground. Then VCC. Then this connect the trig pin at pin 8, then echo pin at pin 9, and this red one is connected to VCC. My connection is complete. Now what I'll do is I'll upload my program. Let me connect the USB. So here I'll open Arduino IDE. See, I have already saved the file as Ultrasonic. Now let me write the program. So first what I'll do is I'll define pin trigger and pin echo. So trigger is at pin 8 and then echo is at pin 9. The variable called duration, which is a long type, I have initialized it as 0. Then a variable float distance and initializing it as 0.0. So now inside void setup, I'll configure the pins. So first I'll configure the baud rate for serial communication, that is at 9600. Then I'll configure the pin trigger as output and echo as input. So trigger as output and then echo as input. Now as I have completed the configuration, now I'll write the void loop function, and here the main thing I'll write. So first I'll write the function for trigger. So digital write trigger comma low, then a delay of 2 microseconds, you have already learned about delay microseconds function. So as I have said, delay microsecond of 2, then trigger high. Now here I am sending the pulse, trigger high for 10 microseconds. So here I am writing 10 microseconds and then digital write trigger low. So this will complete the transmission function. So if I write digital write trigger low, then this process will complete the transmission. If we send a 10 microsecond pulse to trigger pin, the transmitter of HCSR04 will transmit sound waves. Now it's time to receive. Now what I'll write is duration is equal to pulse in this function will return the time and it will be stored in duration variable. So here distance is equal to duration into the formula I have already shown you, 0.0343 divided by 2. By this formula will be getting the exact obstacle distance. So here I am printing the distance up to 2 decimal places and I am using a delay of 100 milliseconds. Why? Because to slow down the printing process. So float distance, trigger pin is defined, echo pin defined, duration is 0, float distance 0, then baud rate 9600. Pin mode trigger is configured as output, echo is configured as input. Now come to void loop and here digital write trigger low, then delay of 2 microseconds, then trigger high, delay of 10 microseconds. So by this we are sending a 10 microsecond pulse to the HCSR04 and it will transmit the sound waves through these lines, and then I am receiving the timings from pulse in and it is getting stored in duration variable. Then I am calculating the distance by simply writing distance is equal to duration into 0.0343 divided by 2. Now it's time to print the distance. So I am using, you can also calculate 0.03. So I am using serial.println within bracket distance comma 2. It will print the distance value up to 2 decimal places. Then using a delay of 100 milliseconds to slow down the printing process so that we can easily visualize the distances. Now program is done and it is saved. Now I'll upload my program. So I have uploaded the program. Now I'll open the serial monitor. So it's opened. See, the distance is showing. I have put a scale between the ultrasonic sensor and the obstacle, and see, you can see the data and subsequently you can check the scale's measurement. See, here I am placing the obstacle at 9 centimeter away from ultrasonic sensor and it is showing 9 centimeter. So here it is at 14 centimeter and now it is showing 14.2. If I move the obstacle, it will subsequently show the exact distance, like it is at 20. It is showing now 20. So this is how the ultrasonic sensor works. Now I think you have the clear idea about how to interface HCSR04 with Arduino. In the next lesson, I'll discuss how to interface RGB LED with Arduino.